Assalamu alaikum. Thank you all of you to watch this video. Today I will tell you about the continuity equation and I will prove continuity equation and how to find and how to is use in our daily life examples I will give you. Consider a mass of a liquid and the content in volume of pipe must be remained constant. There is no source or sink is called continuity equation for fluid. According to the continuity equation, volume flow per unit time of a fluid through a pipe is equal to the product of cross-sectional area of a pipe and fluid speed at any point along the pipe. Now this is example. Now we will take example fluid from here, cross-sectional area, and this is again cross-sectional area. Volume flow from inter is equal to the volume flow from outside output at any cross-sectional area, but the volume of speed is different from different points according to the cross-sectional area. In this area, the cross-sectional area is small and the volume of speed of fluid is large as compared to speed of this point. Now I will tell you more examples. Consider density is each volume density mass divided by volume, and when we take example, this is the fluid of water flow through a pipe and the mass contained I will show you, and the flow of water through in this fluid flow and the pipe of cross-sectional area, and this is the fluid flow through, and the density of mass density is equal to मास को मल्टीप्लाई कर देते हैं. दिस इज द क्रॉस सेक्शनल एरिया ऑफ पाइप A1 and A2. P1 is density and P2 is a density. V1 velocity, V2 is the cross sectional area of different cross sections. Speed increase at that point when the cross sectional area is small. You can see here, and we can write A1 V1, and speed of density is this. These are lines parallel to each other and move from speed increase. Now density rho A1 V1 is equal to rho A2 V2. Both our cross-sectional density should be same. Now we can write equation A1 V1 and A2 V2. Now is the constant equation of continuity. Now I will prove you density is density multiplied by volume V1 for one cross-sectional area and density multiplied by V2 for second cross-sectional area. Now similarly, density volume A multiplied by cross-sectional area. Volume is area multiplied by distance. Now again V2 cross-sectional area multiplied by A2, and the mass flux. This is the mass flux, the mass per unit time flux, and again I can show here this is again mass per flux density. Now both are equal, so we can write here left hand side and right hand side density should be cancelled to each other, and this is the continuity equation. So continuity equation show that the consider ideal fluid flow through a pipe non-uniform size. In this example I will show again, and this example for consider pipe fluid move through along a streamlined steady flow in time interval. Short of element flow bottom of end of pipe distance and density, also this is the density, and the parallel lines of each fluid flow through a pipe, and the cross-sectional area A1 and cross-sectional area A2 are different, but density is here and density here are different, but the density should be same after, because these 1 2 3 4 5 6 7 8 particles are moved at same time, but density should be same and volume should be different. But if different volumes, speed will be different, and here speed is increased. You can write here this equation density and this equation density should be same. Mass per flux density is the mass same, and this equation we can write in this form: mass per unit time is the mass flux density. Mass flux same at both points, because we can compare left hand side and right hand side due to the mass flux. In cross-sectional area of mass contained left shaded region is, and this density A1 and area volume, this density flux and mass A1 V1 and mass flux density A1 V1. When we compare both, then mass flux density AV is constant. It means that the area multiplied by volume is constant for any point of the liquid flow. Consider, I will take example. If you want to water flow through in your garden, and the pipe you will grip in your hand, and you should want to give water at your plants at a large distance further from you, and what you will do, your hand and you are press the cross sectional area should be decrease of the pipe, and then the water will go at different distances at different speed will be increased due to when we compress, and water of the speed water spreading from the end of garden houses increase as the size of opening is decreased with the thumb, and you thumb of press your pipe, and the water of the pipe speed will be increased due to the cross sectional area will be decreased. Now this is the continuity equation in your daily life. Now I hope you all are understood. Thank you very much. Thank you very much.